If a shark is spotted near to Brighton Beach, a lifeguard will activate a siren to warn swimmers. So we've got the sound intensity I of the siren varies inversely with the square of the distance d from the siren where d is greater than 0. So inversely, I know that inversely can be very weird. What this is telling me is that the farther away you are in distance, the less sound you will hear because it is inversely related. See, that is the intuition of the word inversely in this problem. They also tell us that it is known that at a distance of 1.5 meters from the siren, the sound intensity is 4 watts per second. See, per square meter. Sorry. So we need to show that I equals 9 divided by d squared. Now, since it is telling you show, you kind of have to like start from 0. See, you cannot work backwards here, plug in 1.5, plug in 4, and show it that way. You have to start from 0. ¿Cierto? And so the way that you start from 0 here is that, A, you kind of like forget about the 9 for a second, and you go, okay, so how can you get this 9? ¿Cierto? How can you prove that this is 9? Well, I equals k, ¿cierto? Because we still haven't figured out 9 yet, since we are showing, see? Divided by d squared, see? And now I can plug in 1.5 and 4, see? So if I plug in 1.5, it is meters. That's going to be the one on the bottom. So I'm going to have k divided by 1.5 squared. 4 watts is going to be I, so I'm going to leave that there, see? I need to get k alone. So I multiply by 1.5 squared to both sides in order to get rid from the, from the denominator. Equals k. K now will give me 9. See? And now that we know that k is 9, we plug it in over here, and that is how we show that um, I equals 9 divided by d squared. ¿Cierto? It's with these steps shown below. See? You cannot plug in, I insist, you cannot plug in 1.5 and 4 watts immediately. You have to do the k thing. See? You have to show how you figured out that this 9 is 9. For part B, we need to sketch the curve of I on the axis below, showing clearly the point 1.5, 4. So, there's a couple of ways to approach this. I think the best one is making life easy on yourself and just graphing this on your calculator and literally copying the graph. See? Copy the graph and put the important points. So, we go to y equals. We erase this bad boy. We put this guy up here, which we said was 9. Oops, let me erase everything, sorry. We take this 9, we divide it by x squared. We go to window, we copy the window that they give us, which is a y of 20, ¿cierto? A y minimum of -5, oop, nailed it. An x of 6, oh, an x minimum 0, see? So let's graph this. It looks like that. Copy the graph, see? Make sure there's a little bit of a gap here, ¿cierto? From here to here, there's a little bit of a gap. And it should be very close to 6, see? Alright, very close to 6, but doesn't touch. Got it? Am I done yet? No. I still need to show the point 1.5, 4, see? So 1.5, 4. This one you can eyeball it a little bit. Of course, make sure that it makes sense. If this is around 10, then 4 would be whatever, like here, ¿cierto? 1.5, 4, see? So here you get the 2 points by 1 labeling it, the point, and 2 making the graph like make sense. And one of the biggest ways you can do that is making sure that you never touch 6. ¿Cierto? It should look something like that. Oh, and make it end just at 6. ¿Cierto? Don't go like that. See? Leave it at 6. And you'll get full credit. And this little gap here will also give you, or make sure that you get full credit. See? Yep, well, so that's part A, that's part B. Part C. Whilst swimming, Scarlet can hear the siren only if the sound intensity of her location is greater than that. See? So, only if the sound intensity, which you said was I, is greater than, so this has to be greater than, 1.5 times 10 to the power of -6. See, that is like words into math, ¿cierto? Sound intensity greater than whatever number they gave us. See? And so this is where she can hear, So we need to find the values of D where Scarlet cannot hear, it would have to be the opposite, ¿cierto? So not the one on top, because the one on top is can, the one on the bottom is cannot. See? Awesome. So we're using the one on the bottom. My equation for I, we saw earlier, of course, it's 9 divided by d squared. This has to be less than 1.5 times 10 to the power of negative 6. All I need to do is get d squared alone. See? So, let's go ahead and multiply d squared to both sides. So I end up with d is less than 1.5 times 10 to the power of negative 6 times d squared, ¿cierto? Now I gotta get d squared alone. Divide by both sides by this, see? This helps me get rid of that and that. So 9 divided by 1.5 times 10 to the power of negative 6 is less than d squared. I still need to get d alone, so I'm actually going to do square root to both sides. That is one nasty square root. Sorry, it's been a long video. 9 divided by 1.5 times 10 to the power of negative 6 is less than d. See, so whatever this gives me is, well, it's my answer. See, so calculator. We do square roots of a fraction. 9 divided by 1.5 times 10 to the power of negative 6. Okay, it gives me this. See? So 244, 9.48 less than d. Less than or equal to d. See? Why is it or equal to, and I actually missed it earlier, is because if my can is greater than, my cannot has to have the or equal to. See? Because you need to include the value that's like in between. And so the opposite would actually be this. See? I missed the or equal to, my bad, but I noticed it at the very end. I hope that you did as well at some point. That is the explanation. That is number, which one was this? Number 11.